everyone, and welcome to the Spatial Data Analysis and Spatial Econometrics Reboot. I'm working on some data right now. I just want to show you what I'm doing. And in my previous series, I used Map Window as the open source GIS program. Now I'm using QGIS. And it seems to be a little more popular, updated, more supported open source GIS now. So I'm going to use QGIS, and in this video I'm making some maps, and I'm just going to let you watch me as I kind of talk you through it. So I encourage you to follow along with me, and to do that you're going to need the files that I'm working with, and you're going to need to download QGIS. So go to my webpage, which is www.berkeyacademy.com. And link down here, there's also a link in the description of this video to my website if that's easier for you. And you can click down here on GIS and spatial statistics. And this is where I'm putting the new videos and the new links. So over here is a link, QGIS, free GIS software. Just click that and you can download it. It's absolutely free. Also, if you want to truly follow along and use all the files that I'm using, then you can click on this link here, Maps and Data Files Used in GIS Intro 1 video. And it's a zipped file with a lot of files inside. Let me show you what those are very briefly here. So there's a lot of files in there, but most of these files are related. There are two comma-separated values files here that we'll use that have some extra data in it. The rest of these are map files. In each of these groups, NC Major Roads, for example, you'll see several different files with different extensions. DBF, a database file that contains the data. PRG is a projection file that tells the map program what sort of projection that this data is recorded in. Kind of a technical detail that we can overlook for now. There's an SHP file. This is called a shape file. And this is the most commonly used map file out there. It's a little bit older. There are some newer versions out there, but shape files are map files that can be read by just about any kind of mapping program. And SHX. So 1, 2, 3, 4, 5, sometimes there will be 6 or 7 different files all associated with one map file. So we have major roads in North Carolina, places in North Carolina, block groups in North Carolina, and down here NCCO counties in North Carolina. So I'll just unzip all these files, have them in a convenient folder that you can easily get to, download and install QGIS, and then you can follow along with all the stuff that I'm about to do. So come on, join me. Now, if you're familiar with ArcMap or Map Window, QGIS is going to be pretty familiar to you. In this video, I'm going to add some shape files. I'm going to load in some comma-separated value files, and I'm going to do some thematic maps with this data. So let me just go ahead and get started here. Over here on the left side, you have some buttons to add different kinds of layers. And that's one thing I had to figure out here is, what do all these buttons mean? The two we're going to be using here are this one that says add vector layer. And this one down here, the big comma, this is for comma separated values data. So let's go up here and let's get started. Oh, first, I recommend that whenever you start making a map, you create a new project. And so a project in QGIS is going to save your print layouts. It's going to save the map that you have with the various thematic things, all the layers together. It's kind of a wrapper to remember what you've been working on. When I open QGIS, I get a couple of errors that you have to hit OK. But it doesn't seem to affect the functionality at all. So don't be worried if you download QGIS and you get some errors when you run it. Just keep on going and everything seems to work fine. Go to project and then you can say new, and then you can just give your project a name. So I called mine Final Maps for this project I'm working on. So let me show you what I'm doing. Let's add a couple of vector layers here, and shape files seem to count as vector layers. Browse, I've got all my little shape files here in this folder. Let me tell it to filter to where we're just looking at those. So the first thing I'm going to do is add a county map of North Carolina in the United States of America. And then I'm going to get rid of the fill color here. So I'm going to double click on the little blue fill and tell it I just want it white. Now you could also make it transparent, but in this case this is my background kind of that I don't need to see through. We'll change some other things to be transparent later on. Now I want to add place polygons. Now these are some files I got years ago from the United States Geological Service. And this just shows kind of cities and towns. So here in North Carolina, this is Raleigh, Durham, Greensboro, Winston-Salem, Charlotte, and Wilmington down here. Let's add some more. Another thing I want to add is the road system here. And so this just shows all the major roads and highways, not all the roads, but just the major ones here. So we can kind of get an idea of what the road layout looks like. Now those I want to make a little transparent because where they're very dense, it's kind of covering up the details here. So let me click on that little line, and you can just slide this little transparency meter here. Let's try about 50% here and see what that does. Yeah, now those greens aren't quite so dark and splotchy, and when we zoom in we can see the borders behind them very well. Now, the next layer I'm going to add is hospitals. So this study I'm doing has to do with, well, instead of, I already made a shape file out of this. Instead of doing that, let me load the comma separated values file, show you how to make a file, map data that you have the longitude and the latitude for. So I'm going to click the big comma here, and that brings up a little window. Let's browse. And here, data hospital with longitude and latitude. Let me just double click that. And it brings up a little preview window of what we're looking at. So this is the little code I gave each hospital for this study, the number of beds, longitude, latitude. Let me make sure, am I getting that right? Yeah. Latitude is the Y, longitude is the X, and the name of the hospital and the city that the hospital's in. And since this has longitude and latitude in it, geometry definition point coordinates. Tell it the right fields if it can't find it, but it's going to look for words like lon and lat, x or y, and it'll figure these things out sometimes. And let's just hit OK. So it gives us a warning here that the coordinate system was undefined, and it's using kind of a default coordinate system. I'm not a geographer. I don't tend to worry about those things that much. I get the idea that they don't matter so much unless you're trying to mix two very weird geometries together, or if you're really looking for precision, like down to the meter level or the foot level. All right, so here we see the locations of the hospitals in North Carolina, these nice little blue dots. I don't want them to be little blue dots, though. I want to make these hospitals larger if it's a larger hospital and smaller if it's a smaller hospital. So we can right-click on the data here that we just brought in, right-click, and we can go to Properties. And here the first thing that pops up is called Style. And instead of single symbol up here, we want to change it to graduated. And instead of color, different colors for different size hospitals, I actually want the point to get bigger and smaller. So we change that method, color to size from 1 millimeter to 8 millimeters. I've found that for what I'm doing here, 1 millimeter is just a little too small. So I'll change that to 2, and 8 millimeters is a little too big. So let me compress these to where the sizes aren't quite so large. So going from 2 millimeters to 6 millimeters. Tell it what variable you want to use here under column. I'm going to use the one called beds. And you can click classify. And you can tell it how you want it to classify it. Equal interval just splits them into equal width ranges. You can choose how many classes you want. 5 works fine here for my tastes. Just click apply. And let's see what we have. So now you see that we have larger dots for larger hospitals and smaller dots for smaller hospitals. And that kind of gives us a little bit more information about this map. Let me add another vector layer here. This is the North Carolina block groups. Let me load those in. So these are block groups. These are the lowest level that the Census Bureau will give you any kind of demographic data. Now the Census Bureau now won't even give you demographic data at the block group level because we don't have the long form data anymore. But if you want to do some small area demographics and look at incomes and things, you can go back to the year 2000 census data. You can get some useful information about those block groups. So let me turn those off by hitting the little X here, because that just kind of covers up everything we're looking at, but we'll bring those back in a minute. In this study, what my grad student Mariama Sidibe and I did is we constructed a model where we calculated the driving time between every block group and every hospital. And so what we used was the block group centroid here. So centroid would be a dot roughly in the middle of each of these block groups. And we found the closest road and approximated the driving time between the block group and the nearest hospital. We made a huge matrix of those, and we used a program called GAMS, General Algebraic Modeling System. And we used it to first assign people to hospitals, but hospitals fill up. So if you have a lot of people that live close, whose closest hospital is a very small one like this one here, that hospital is likely to get filled up. And we wanted to kind of assign people to hospitals in an efficient way, but once a hospital kind of meets its quota, we have to assign people to a hospital that's a little further away. And we asked it to assign people in the most efficient way, basically minimizing the total travel time that people have to spend to get to the quickest hospital. And we did that assuming a certain rate of hospital usage, breaking people into whether they were insured, have health insurance, or don't have health insurance. And we found data suggesting, as makes sense, that people who have health insurance use hospitals more. And we estimated for each block group what percentage of people have health insurance and what percent don't. We don't have actual data on it, but we were able to approximate it. And then we changed things to assume, well, what would happen if everyone got health insurance and people started using hospitals more? How would things change? So that's what we're going to add to this map, is which of these block groups were most affected by having their hospitals fill up more quickly and they have to be assigned to a hospital further away, and now those people are having to drive a lot further to get to their closest assigned hospital, if that's the way things really work. So let me read in another comma separated values file here, where what I have is just a CSV file. So here's the CSV file that we're going to be reading in. It tells us the block group. It tells us the average distance people in that block group had to travel before everybody gets healthcare, and then the average distance afterwards, looked at the difference. And so in this file, I just saved the ones where on average, people in that block group were going to have to travel 5 minutes more to get to their assigned hospital or greater. So here we see 21 minutes, 9 minutes, 17 minutes, etc. How many people live there, and some other demographic information. And here's the FIPS code. This tells us how to match this data with the block group data. FIPS stands for Federal Information Processing Standard. Counties have FIPS codes, states have FIPS codes, block groups, tracts, all those good things. Okay, so let's go ahead and read this in. Let's close it here. So let's add in comma separated value, click the big comma, block group. Okay, there it is. And here we don't want it to map this data because there's no X and Y field. It tried to find one. Average distance X, average distance Y, but that's not a longitude and latitude. So we click over here, no geometry, and then it won't try to actually map this data yet until we match it to a mappable layer. So we click OK, and it just adds this little text file here, and we can open the attribute table, right click, open attribute table, and we can look at it to make sure that it read in correctly. And so what we want to do is go to these block groups, the purple things that we got rid of here because they were annoying. Right click on those, go to properties. And what we're going to do is add a join. So click on joins. click the little plus sign down here. And what we want to join is layer, most affected, block group 2, that little file we just read in. What's the join field? FIPS code. And the two fields don't have to be named the same thing, but I just happen to have a field in the block group data also called FIPS, and that should match up. Let's give it a try. So apply, OK. Now to see if this worked, let's right click again on the block group data and go to Open Attribute Table. If we go all the way to the end with this little slider, we see whether it worked. And when I first did this, I kind of went crazy for a minute because I was like, oh man, it didn't work. But then, this is not all the block groups. Only some of the block groups are in that file. So here we see the ones where we got matches. And so the list of the most affected block groups wasn't all 5,200 and some block groups, just some of them. So here, looks like it worked. Okay, so how can we use this? Well, now that we have that additional information joined to this purple layer, we can go to right-click Properties, and we can do a similar thing that we did with the hospitals. Go to Style. Instead of single symbol, we want graduated. But this time, instead of size, we don't want to make these block groups larger. That wouldn't make any sense. We're going to use a color. So Method, Color, give it a column. And the column we want to use is a column I call diff, for difference. What's the change in the driving time estimate that people have to go through? What kind of color ramp do I want to use here? Red to green. Let's try red to green, but instead of going from red for low values to green for high, click Invert. And that will switch it to where red are high values, where they have to drive a lot longer. Green, not much difference. Classify, let's use more than 5 classes here. Maybe 10. Equal interval, okay. And apply, okay. And now let's add that layer back. Now this is a little busy. Let's get rid of the roads here. Let's get rid of the places so we can just focus on where these block groups are that have been affected. And here we see some areas that are near kind of small hospitals that are probably being redirected to some of these larger hospitals when they fill up. So in this case, for example, I looked at the results, and originally these people were going to this hospital, was the closest, and now they're being redirected to, maybe it was this one? So it's a lot farther away. So that's just a little quick introduction to QGIS. But it's just, if you're going to be doing data analysis with spatial data, you have to be able to know how to use some of these mapping tools. And this is kind of how to do it. Let me show you one last thing. How do you save something that you did as a map file, as a shape file? So for example, these hospitals that we read in, how would we actually save this as a map file, so instead of a comma separated values file, so we can just load that into a mapping program directly in the future? I mean, I like how easy it is in QGIS. You just right click on the layer that you want to save, and you click Save As. And then a little window pops up here. You can choose what kind of file you want to save it as. An Esri shapefile is the default here. And you just give it a name, or you can browse to where you want it to save it. Yeah, I can say Hospitals 2, save, and now you've got that file after you hit OK here. And by default, it's going to add that layer back in. And when it adds it back in, it's just little green dots that don't have the sizing that we did before. One other thing I'll show you, since I already showed you the transparency, is what if you had something that was covering up? You can rearrange the layers down here in this list of layers. So for example, the order that you load your files in is going to determine initially what's on top and what's on bottom. So one way to fix that would be, like the places here covering up the hospitals. So one way would be to go Properties and change the transparency, make it a little more transparent, and then we could see those hospitals shining through. But you can also drag and drop these things to tell it what you want to put on the bottom. So let's put the counties on the bottom, the places next, etc. Okay, this video has gotten too long. I think now you see some of the basic ideas about how to create a QGIS project. When you're done, just save the project here, and it'll save everything just like you're looking at it. I'll make another video later on about how to make a nice little print layout for a paper or something like that. But hopefully this is the start of the spatial econometrics spatial data reboot. Hopefully over the next couple of months, I will actually show you how to estimate spatial econometric models and do some other kind of basic spatial data analysis in R. If you like this video, if you like this project, please consider liking this video, subscribing to the channel, and if you really like me, consider supporting me on Patreon. Thank you very much. Good luck.